All right, here we have a little free response type question that involves knowing the series expansion for e to the x, and then doing some things with it. And notice it says alternating series error bound. So let's go ahead and jump in and do it. All right, so f is the function defined by f equals e to the negative 3x. I want to write the first four non-zero terms in the general term for the series expansion of e to the x. So we've talked about this. We know, or you should know, that e to the x is 1 plus x squared over 2 factorial plus x cubed over 3 factorial, plus it keeps going on and on like that. But look, this says the first four non-zero terms. So 1, 2, 3, 4 terms. So that's all we got to do. If we wanted the next one, we would write it x to the fourth over 4 factorial. And then it says, and the general term. So I'm going to write plus dot 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 plus. This one's a little bit easier than the sine and the cosine, but it's x to the n over n factorial. So, looks like, and that is the one about x equals 0. There's a variety of reasons for that, but I'm not going to get into that here. All right, so it says so we've done part A. Good, way to go. All right, part B. Use your expansion from part A to write the first four non-zero terms and the general term for the series expansion of this thing right here about x equals 0. So we're doing the same thing. Instead of having e to the x, we want e to the 3x. So everywhere there's an x, we need to change it over to a negative 3x. So for part B, we get e to the negative 3x is equal to, all right, I still get a 1. That doesn't change. And then I get minus 3x because that replaces the x. And then I get plus plus boink boink squared over 2 factorial. And then I'll put a negative 3x in here. And then I get plus boink boink cubed over 3 factorial. And again, I'll put a negative 3x in here. And then plus dot 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 negative 3x to the n over n factorial. And, you know, it's up to you if you simplify this or not. I'm going to go ahead and, am I going to do that? I'm going to simplify some things here. I'm going to write equals 1, and then I'm going to write minus 3x. And then what I'm going to do is, I'm just going to take note that I'm really actually only simplifying one thing here. This negative is going to get squared out. So I'm going to write plus 3x squared. You could write out as 9x squared if you wanted, but I'm just going to leave it like that, over 2 factorial. And then this is actually another spot where I'm going to change it. This is a negative that's being cubed, so that's going to, 2 of them will cancel, but we'll be left with 1 left over. So then I get minus 3x cubed over 3 factorial. And that's good for me. And then I guess we'll go like this. You know, so we're going to go negative 1 to the n times 3x to the n over n factorial. Why am I doing that? Because, you know, I looked ahead a little bit here and, you know, it said alternating series error bound. So I'm going to write that as the alternating series piece. May help, may not. All right. So let's see. Did we answer that? Use your expansion part A to write the first four non-zero term in the general form. All right, we're good to go. All right, so let's do part C. Evaluate the first 3 terms for x equals 0.5. So that is part C. E to the negative 3 times 0.5. And now I'm only taking the first 3 terms, so I'm going to write approximately instead of equals. You would need all of the infinite number of terms to have it be equal. So I'm going to write approximately. All right, I get 1 minus 3 times 0.5, and then plus 3 times I'll write it like this. Times 0.5 squared over 2 factorial. Is that the first 3 terms? It is. And then if I write that out, I want this to be a little bit bigger. If I multiply that out, I think we wind up getting 0.625. All right, so I've evaluated it. I'll put a little box around that. Not going to box those answers up above. And then I guess this is part C. There we go. All right, so the last part. Use alternating series error bound to estimate the error of your answer of f with f. Hold on a second. All right, there's a little typo here. This should say not f of 2, f of 0.5. So, yeah, so we want to use alternating series error bound to say how close this is to the actual f of 0.5. So what are we going to do? Well, we just talked recently in these videos about alternating series error bound. What we say is that you have to go to the next term to figure out what the error might be. So we used the first three terms, this one, and this one. So what I'm going to do is the absolute value of this term right here is going to be a ceiling on the error of the 0.625 for the actual e to the negative 3 times 0.05. So all I got to do is I'll circle this. We're going to bring this down here. I'm just going to write 3 times 0.5 cubed over 3 factorial. And then I'll go grab my calculator. Another way to write this would be to write the actual term, 3x cubed over 3 factorial evaluated at x equals 0.5. To be honest, I kind of wrote that in a backwards way. You might write this and then write that. Either way, plug it into a calculator. I get 0.5625. That one felt like I should carry that last decimal there. But that means that this thing is within 0.5625 of the answer. So, it is what it is. That's the max error based on alternating series error bound. Hopefully this question makes some sense and you're getting more ready to be able to answer some of these on your own. See you in the next one.